Hi, welcome to Unit 6, Lesson 2. Today's essential question is, what does a radical expression mean? We are going to add and subtract radical expressions once we're done simplifying them. Remember from the first lesson that the small number in the top part of this sign is called the index, and that tells me how many factors I need to break out of the radical. In other words, it's what exponent I will undo. So what exponent can be undone? Remember, exponents just basically tell me how many times to multiply something. This can undo exponents. This thing inside is called the radicand. That's a thing which we're trying to simplify. It's a thing which we are undoing the exponents on. It's sort of like the dividend when you divide. And finally, this is just called a radical symbol. I went outside the box there, but now the 4 through 16, if you remember from the first lesson, we tried to break this up into as many factors as I need to break out of the radical. So this is still the fourth root, and 16 is 4 times 4. 4 can break down into 2 times 2, and then that can also break down into 2 times 2. So I have a group of 4 2's. This is the fourth root of 2 to the fourth power. Therefore, the 4 and the 4 will cancel out to just get us 2. In other words, I took a group of 4 2's out, and there's nothing left inside the radical. The fourth root of 16 is 2. In other words, 2 to the fourth power is 16. Now to break this up, you're trying to just break it into as many factors as you can. But the first thing you need to pay attention to is, what's my index? How many factors do I need to break out of a radical? So in this case, it's a square root, which means I just need 2 to break out. Now you can break down 64 however you want to, but I noticed that 64 is a perfect square. It's 8 times 8. And I also have 4 y's. I can continue to break down the 8's into all 2's, and you can definitely do that. But I'm looking for groups of 2 at a time, and I already see a group of 2 here, and a group of 2 there, and a group of 2 there. And each time I take out a group to the outside of the radical, one escapes to the outside, and the other one goes into hiding. And so I'm left with 8 times y to the second power and the square root of nothing. So just 8y squared would be my answer. Okay, let's move on to the next one. This is all review, so that's why I'm going over it pretty quickly. Now, I'm looking for perfect cubes. Now, if you don't remember your perfect cubes, it's 1 to the third power, 2 to the third power, and so on. I'm going to pause. I'm just going to list all the different perfect cube roots. You can see I've listed them all now. And I said perfect cube roots. What I meant was the perfect cubes up to 10. So you'll be expected to kind of know these roughly what they are, because they're going to help you. I want to get rid of this third power. I'm looking for one of these as a factor of 54. 1 can go into 54, sure. 8 can't go into 54. Can 27? Well, it sure can. It's 27 times 2, and you would have found that out if you divided by 2 anyway. What's nice is that this 27 we know is going to break into 3 times 3 times 3. It's a perfect cube. Times the 2 from up above, times r times r times r times s 6 times. So r to the third, so it's going to be 3 r's and 6 s's. I don't know if I'm going to fit it in there. There you go. I'm looking for groups of what in this index? 3. So a group of 3 here, group of 3 there, 2 groups of 3 here. For each group, 1 on the outside. 3, r, and then 2 s's. Don't forget the index is 3. What's left inside? It's a 2. If I take the square root or a third root of a fraction, it's pretty easy to divide the fraction. 36 divided by 3 is 12. What does 12 factor into? Any perfect squares? Yep, 4. Again, I'm going extremely fast now because we've done so much of this in class or otherwise. 9 into 162. Well, if 1, 6, and 2 are added together, I get 9, which means that this should be divisible by 9. That's a trick. If the numbers themselves, if you add those up, equal a factor of 9, and this is going to be divisible by 9. If you don't know how many times, it's time to do division. 9 goes into 16 once, 7 left over, bring on the 2, 18, 9 times 18. So it would be 2 times the square root of 18. So I'll factor that out. 2 times square root of 9 times 2. That's 3 times 3 times 2. Factor out the 3. Multiply the 3 and the 2 on the outside equals 6 square roots of 2. Now, remember back when we were first learning about variables, back at the very beginning of the year, and we talked about something called like terms. Like terms are when you have the same base to the same exponent. Like if I had an x plus a 3x, I end up getting 4x's. Now, in this case, we're not going to be talking about actual variables, but we can talk about the same bases. Now, I'm looking at the indexes and the radicands to see if they match another index and a radicand. For example, I just highlighted one of them. Square root of 2 and this square root of 2 are like terms because they have the same index, same radicand. So like terms in terms of what we're doing now have the same radicand, same index. Index is 2. Radicand is 2. They're like terms. If I add those together, the square root of 2 plus 5 square roots of 2 would be 6 square roots of 2. Because you have 1 of something plus 5 of something equals 6 times square root of 2. It's like having 1 apple, blue apple looks like, plus 5 apples, more like a pumpkin, I guess, equals 6 apples. Okay? Now, these ones don't have the same index and the same radicand. We could try to break them down to see if we get something similar. So, let's try to do that first. If I break down 18, 9 times 2. Take up the 9, it's 3 and 3. 3 comes out. Square root of 9 is 3. 3 square roots of 2. That's a like term too. I could add that to all of these ones. Those are like terms. If I try to factor out 32, that's 16 times 2. Square root of 16 is 4 because 16 is 4 times 4. I could take 2 out of the radical there. So, sorry, 2 of the 4s. 8 times square root of 2. That's another like term. In fact, all of these, after I simplify them, would end up being like terms. They all will have a square root of 2 left over inside of the radical. So I'd get 15 square roots of 2. So all of these are like terms. But these are unlike terms. They have the same index but different radicands, or they might have the same radicand but different indexes or indices. Now we can add expressions that are like terms if they have the same index, the same radicand. We do a check. Okay, let's look at the radicand here. It's 2. What's the index? Also 2. So I know these are like terms, so I just take the coefficients by the radical sign and I add them together. 1 and 3 make 4 times the square root of 2. 1 square root of 2 plus 3 square roots of 2 is 4 times the square root of 2. I check this one. Do they have the same radicand? 3, 3. Same index, 2, 2. Yep, they're like terms. And then I just add the coefficients together. 4 plus 2 is 6 square roots of 3. These have the same? Yes, they do. Same index, same radicand. So then I could subtract them. 9 minus how many? 1 would be 8 square roots of 5. They have like terms, same index, same radicand. They can be added or subtracted. You might think to yourself at the beginning of this problem that these are not like terms. You have a different radicand. But we've learned to simplify expressions containing radicals so that way we would be able to make them like terms. Because eventually, after I simplify all this, you're going to get 2 square roots of 3, which make these like terms now, and I can subtract 2 square root of 3. Again, these ones are not like terms, but if I simplify the radical, if I'm factoring into its parts and trying my best to simplify, I'm trying not to be lazy, I'm trying to remember to write all my numbers down as I go. It's going to be a lot of writing on your part, but it's going to be worth it to not get the problem wrong. Because now you can see that my radicand simplified to being 5. 9 square roots of 5 plus 2 square roots of 5 end up being 11 square roots of 5. Finally, on part F, you'll again break this down into its parts. 6 times 2. Keep going. We will make like terms eventually if I continue to simplify. It won't always happen, but most of the time it will. This will be 2 times 2, because that 2 comes out here. Square root of 3. Need some more space. So I have 3 square roots of 3 minus 4 square roots of 3. I get negative 1 square roots of 3. It should be times the square root of 3, in case you've forgotten. But those numbers on the outside are being multiplied. Okay. What if you have 3 terms to add or subtract together? Again, you want to make sure they're like terms. Now you notice I'm going to have 2 different terms in here. I have the square root of 2 here and here, but the square root of 5 is unlike those other ones because they have a different radicand that I cannot simplify. 5 is as far as I can go, so I add the purple terms together. 2 minus 6, negative 4 square roots of 2 plus the square root of 5. Over here, we look for like terms in terms of the same index and the same radicand. Looks like all of these are like terms conveniently, so then I could just look at the coefficients, 12 and 5 and negative 2, and I'm getting 15. 12 plus 5 is 17, minus 2 is 15. 15 times the square root of 6. Now the square root of 6 doesn't have any perfect squares, just 3 times 2. I cannot simplify that radicand. However, these ones look like we need to do some simplifying. 24 is 6 times 4. 54 is 9 times 6. Then we have 8 times the square root of 3 times 2, so the square root of 6 isn't going to go anywhere. But what do you notice? All of these other ones have 6's in them. So eventually we have to try to factor this out a little bit more, get the perfect squares out of there. Don't forget the 6 that you have. All I'm doing right now is I'm factoring. Don't forget the signs. And I'm going pretty fast, aren't I? What should you do if I'm going too fast? You should be able to do what with this video? Pause, rewind, and rewatch. Now I have them all in terms of like terms. The square root of 6. 2 plus 3 plus 8 is going to be 13 times the square root of 6. 5 and 8 make 13. These are all like terms here. 3 minus 5 plus 2. 3 minus 5 is negative 2 plus 2 would be 0. Square roots of 7. 0 times the square root of 7 is just 0. Okay. That's all we have today. Make sure you take adequate notes. Make sure that you answer the questions in the summary. Hope you have a great evening.